So it isn't just a secret review for a secret test that we didn't know we were going to have until now?
No, no, there's no secrets, no no puzzles.
So all of them are open up now.
What's up?
So everything's open up. All the notes are open up for.
All of chapter 9 is opened up, like the videos and some other stuff.
Okay. Go through them all then.
Okay. So part series of some a sub n times x minus c to the n is equal to a naught plus a1 times x minus c plus, there's not enough space here. Write it over here. A naught plus a1 times x minus c plus b2 times x minus c squared plus all the way till bn times x minus c to the n. Okay. All right, so here's the theorem. Given any power series of n equals 0 to infinity of a sub n times x minus c to the n, there are exactly 3 possibilities. Number 1, the series converges absolutely for all x in R. Be cool if I use the math symbol, or is that weird?
For absolutely what? For all x, how you write this?
So real quick, right? Yes, this is for all.
For all.
For all x. This
Okay.
is lowercase epsilon, the Greek letter, means
Okay.
elements
Yes.
of the real numbers, R.
Okay, got you. Thank you.
But if you want to write converges from negative infinity to infinity, that's the same thing, right? I just forget if we're using the symbols or not. I can't remember. Okay. And the radius of convergence is R equal to infinity. So the first scenario is that it converges everywhere, absolutely. That's what number 1 is saying. Number 2 is the series converges only for x equal to c and diverges for all other values of x. And the radius Okay, yeah. And the radius of convergence is r equal to 0. Yeah, so in other words, the scenario 2 is saying that it converges only at one specific number, c, and then everywhere else. So meaning there is no radius, right? It's only at one point. Number 3. The series converges absolutely for x an element of c minus r, c plus r, and diverges for x less than c minus r. And
I'm sorry, for X what?
x
No,
an element
the one below, the last
x
line.
less
X
this right
less
here?
than, oh, okay, less than, okay.
Less than c minus r.
Thank you.
And x greater than c plus r for some number r. Where r is between 0 and infinity. My radius has to be positive. That wouldn't make sense otherwise. Okay.
Well, R is going to be greater, and then R is going to be less than infinity. Right? Well, basically, what's talking about there in that theorem.
Right. X is less than c minus r, and x is greater than c plus r. So basically, it diverges outside this interval, is what it's saying. You see that?
Okay.
Outside of c, beyond c plus r and below c minus r.
Okay, I'm understanding.
Okay. All right, so the next question. All right, let's do an example, I think. Yeah. You guys cool if I turn the page? Okay.
Yeah, it's fine.
All right, first example. Forgot my fancy notebook today. Find the interval and radius of convergence for the power series for this power series here. N factorial times x to the n. Okay, so when you're doing power series, most of the time you're going to deal with root test or ratio test. And that's going to help you create the radius of convergence. On this one, as soon as I see a factorial, you should be thinking you should use a ratio test. So that's the easiest way to deal with factorials. I cannot do a root test here. All right, so here's a note. Use root/ratio for power series. This is, I don't want to say all the time, because I don't say always unless there's a theorem or proof behind it. I'm going to say good rule of thumb. It's going to be one of these. Okay. So we know that AN is equal to this guy, right? AN plus 1 would be equal to n plus 1 factorial x to the n plus 1. So the ratio test says you take the limit of this guy over this one, and it must be less than 1 in order for it to converge. So the limit of AN plus 1 over AN as n approaches infinity must be less than 1. Let me double check though. Pretty sure that's right. Ratio root, yeah, less than 1 for it to converge absolutely. All right. I'm going to check my theorem real quick. All right, so we're going to get the limit of this guy over this guy
So the n factorial cancels out the factorial and the n plus 1, doesn't it?
Yeah, it should cancel. We can expand this guy to cancel one of these. So yeah, let's show that. And this must be less than 1 for absolute convergence. I'm just going to write that one there so we remember. So I'm going to break off n plus 1, subtract 1, because that's the rule of your factorial. I'm going to break off a piece of the x here. And then down here, I'm going to leave it as is to cancel. So then these are gone, right? Leaving me with n plus 1 times x over, well, it's gone, right? It's just 1. Is this less than 1?
Looks
Which is this limit?
no. It looks like it's gonna be infinity. Like it being infinity over 1 is infinity.
Yeah. This limit is infinite and not less than 1. Therefore, 3 dots in math symbol, therefore, this series diverges. Although,
And that's from the root test, right? I mean,
yeah,
by
it's
doing
because of the root test, because this needed to be satisfied, and it wasn't, right? Oops, sorry, ratio test. Is there But remember, x can be anything, right? Is there an x that would make this converge? The series diverges by the ratio test for all x except what? Is there an x, or is it all x? Does x even matter?
Except 0.
Yeah, if x is 0, then it doesn't matter what n does anymore, does it? So this is going to be what was it? Possibility number 2. So the series converges at x equals 0 and diverges everywhere else, just to keep it simple here. And that's what we're saying.
This is called like conditionally convergent.
It's going to be absolutely convergent, but only at x equals 0.
Okay.
So we'll just say it converges there. But these questions are going to ask you, does it converge or not? But then they'll ask you, what is the radius? Right? What is my radius of convergence for this question?
What was the question?
What is the radius of convergence? In other words, how big is the interval for where this series converged?
Zero.
Remember how we said on the theorem, right? We said if it converges to a specific number c, then the radius of convergence would be 0 because there is no actual radius. It doesn't go from here to there, it's just one spot. So 0.
Oh, okay, that makes so much sense.
So radius of convergence is 0. Then the homework you'll write r equals 0 or something like that. Let's do one that actually converges more spots here. All right. So next example. Find the radius and interval. So they're going to ask for both of convergence for the power series. All right. So you see the factorial, right? We should use the ratio test. And since the ratio test has the absolute value built in, we don't have to worry about the alternating piece. so we're only going to look at the regular AN. And AN plus 1 would be x to the, what would that be? I'll just go ahead and write it. Do an extra step, so I'll make a mistake here. So that'll be 2n plus 3 over over 2n plus 3 factorial. Okay, you see what I did, right? I'm plugging in n plus 1 for n. Simplified it here, so this is my am plus 1. Now we can do our ratio. So the limit of the absolute value of am plus 1 over an.
For the top variable where it's x to the power of 2 times n plus 1, isn't the 2 not multiplied by the 1, so it would just equal x to the power of 2n plus 2?
No, since it's right, since the 2 is multiplying the n, and I'm substituting n plus 1 for the n.
Oh, okay, I see.
I need
Sorry.
to multiply it. No, it's good to question because you never know. I might forget something. Appreciate it. Okay. So this needs to be true, right, to converge. So let's see if it is true. 1 second. All right. So what was I? All right, let's see what happens. The limit as n approaches infinity of this ratio. So I'm going to go ahead and skip the fraction step. So this will be first, right? Two n plus 3 divided by this guy, which means it'll flip over, right? 2n plus 1 over x to the
By the
2n plus 1.
dispenser, I saw enemies, I saw what I was.
That makes sense. This step right here.
Yes.
Skip the minor step, but if you don't see it, let me know.
Because we just did the inverse of the very top, right? That's what we did.
Yeah, you just take the reciprocal and then multiply, right? It's the fraction step.
And then the factorial you cancel out again.
Yeah, we're gonna have to expand it a couple of times, then we can cancel. Okay, so we're gonna break off 2 pieces. And leave it with the x squared here. You guys agree with that? Top part? Now expand this guy. to here. And then we'll cancel the factorials, the x part, and then we'll see if that is still less than 1. We have the limit as n approaches infinity of x squared over 2n plus 3 times 2n plus 2. Is that less than 1? This is more of a question, right? Not a statement. What limit is that?
It's still infinity.
Remember, it's n going to infinity.
N not x. Okay. Sorry. Yes. We're going to 0.
Yeah, we'll go to 0. Does it matter what x is? Will this always be 0?
No.
Yeah, it doesn't matter, right? What x is?
It doesn't matter what the
Yeah, it
answer.
doesn't matter because
The 0.
yeah.
Yeah, the whole thing is 0, right? So
Yeah.
this limit is 0, which is always less than 1 for all x, right? So therefore, the series converges for all x by the ratio test. Okay, so let me try to figure out how to phrase this better. Real quick here. Interval of convergence is everywhere. Radius of convergence is infinite because the radius keeps going on both directions forever. So you would say that R is infinite. So this is how you're going to answer the questions at the very end. I just run out of space. So part 1 would be something like this, and then 2, you'll write the radius and the interval. And then down here is the overall conclusion. So right underneath you'd say, okay, interval convergence is all real numbers or negative infinity to infinity, and the radius is infinite. That's how you would put it all together. I just didn't have space. But does the main idea make sense so far?
So far.
Okay. Now let's do another one then. And we'll move on to something else maybe. So the question is, find the radius and interval of convergence for power series three times x minus 2 to the n. You agree that this converges for sure at when x is equal to 2, right? You see what I mean?
Yeah, because it just will be 3, right?
It would be 0.
Yeah.
Be gone.
Yeah. Everything is 0.
Yeah,
Okay.
if x is 2,
Yeah, yeah.
then this converges when x is 2. So let's find out what happens around 2. So we already know for sure it's going to converge somewhere, right? But let's do our work here. So a sub n is equal to, well, we could do the ratio, but we could also do the root on this one. Because see how as a power n, we could cancel the n with the root test. Or we can do the ratio again if you want to. It doesn't really matter. So the root test said that the limit as n goes to infinity of the absolute value of the nth root of a sub n must be less than 1. The same rules as the ratio. So this n will cancel with this one. So let me show an extra step here. So we're going to have 3 to the 1 over n times x minus 2, because the n's would cancel, right? Do you agree with this so far?
Yes.
So now take the limit. What's going to happen to this guy? To the 3.
0.
Well, the power will go to 0, right? What is any number to the 0?
1.
So this is really a 1. Right? So then, solve for x. But don't forget that I technically still have my absolute values. Don't forget. No, we can't forget that. Now, if you remove the absolute value bars, do you remember that we're going to get this rule here to deal with the value in the middle? You guys remember or no?
Yes.
So whenever you remove the bars, you got to put whatever number's here, put the negative side over here, positive and negative. So now solve for x, we get plus 2, so that would be 1 and 3, right? So you add 2 to all 3 sides.
Yes.
Yes.
So my interval of convergence is 1 to 3, correct?
Yes.
My radius of convergence, how much distance is this? What does radius mean?
2. It's radius should be 1, right?
What's the center of 1 and 3?
2.
2, right? So going out in either direction, yeah, you're right, it's 1.
1. Because it's half the radius is half the diameter, so that's why we said 1, right?
Yes, exactly.
Okay.
So it's like half the distance, right? So in the homework, they're going to ask you, what is the radius? What is the interval? And you need to use a test, right? This is the root test here. The root test gave me this restriction, which allowed me to find and create an interval of convergence. And it's not equal to 1, right? Because we said it was equal to 1, then we know nothing. Actually, let me double check. We know, I think it's inconclusive. Yeah, there is no conclusion, inconclusive. If your limit is 1, then the test didn't work. Okay. Do you have any questions on these 3 examples? Does it make sense? Is any of it weird?
So this one didn't diverge or converge. Is there no conclusion, right?
This one converged only here on 1 to 3, between 1 and 3, not including the endpoints. Remember we said for sure 2, right? Remember we said at the beginning?
Yes.
So 2 is in the middle, so that was right. One second. Make sure I don't forget anything on this question. So by the ratio test, this series converges when x minus 2 is less than 1, or on the interval 1 to 3, and diverges when x minus 2, when it's greater than 1. X minus 2 is greater than 1. Or outside 1 and 3. Now we should, according to the book, there's something I forgot. We should be checking the endpoints. Like, is it for sure not converging at 1 and 3?
What did you say again? Can you repeat, please?
We need to check the endpoints. I can't just say for sure. So we're not done. Like, I'm 90% sure this is true, but we need to check. Okay, so that's an extra step I did not do. Last time it didn't matter because we didn't have an interval, but now it does. But we must check x equals to 1 and x equals to 3. That way we can find out, do we use brackets or do we use parentheses? So we're going to let x be 1 and see what happens and let x be 3, and then simplify. Okay, so let x equal 1. We would get 3 times, sorry, I should write the series first, not skip steps. Three times, what is it? So let x be 1, we'd have negative 1 to the n, correct?
Yes.
So let's find out, does it converge? Does this thing converge, this new series? So take the limit of a sub n, right? It's the first thing we always do is check the sequence. The limit of 3 times negative 1 to the n, does this, what is this limit?
Can we use geometric series with this one or no?
Well, you could, but I'm using the divergent test.
Oh.
That's the first thing you should always
Test.
try first.
Yes, yes, I remember you said that.
Because taking the limit should be easy compared to using a whole another test. So just find a limit and then you can move on if it doesn't tell you anything. Because the diversion test says if the limit is not 0, then the series diverges. If the limit of the sequence is not 0, then the summation of the sequence will not converge.
But this limit is not 0.
It's not, right?
Right.
It does not exist, right?
Yes.
Because it alternates forever. Therefore, by the diversion test, the series diverges. So we're not going to use x equal 1. We're going to put a parentheses. So now let's test x equal 3. So if I plug in 3, what was it? It'd be x minus 2, so that would be 3 minus 2, right? You can already see what this is going to be, right?
I think it still do not exist, right?
What is the limit? The limit of a sub n as n approaches infinity would be 3 to the 1 times n, but that limit should be obvious, right? It's not 0. Therefore, by the divergent test, the series diverges. So that means that back at our original conclusion back here, it was cool to put parentheses. Oops, my blurry. You see that? Originally I said there, but I can't just say that. I need to check, because sometimes you can put a bracket on one of them or both of them. So you have to check by letting x be 1 and x be 3. So you check the endpoints by doing this. And then the series that results by letting x be the endpoints will require tests from previous sections. It could be anything. Luckily on this one, the diversion test finished it off really quick, but we could have used something else like a geometric or whatever you want to do.
But in this case, it's better to use a geometric, right?
You could have said that R, well, geometric rule says if R is 1, right, then it diverges. Say, could have done that, but I think divergence test should always be done first, because the limit should be something that you're good at. And you can see that this is just going to be 1 forever, right? Oh, sorry. This is going to be 1 forever. So taking a limit of this, there's no work to do. And knowing that it's not 0 is enough to say, you know what, that's it. It diverged at the endpoints. Okay. I guess that's it for this section, I think. Just remember when you're doing these problems that you check those endpoints, okay? All right, let's go to another section. Double check everything. You can just take a small break. It's 9:07. Let's come back at 9:15. Go ahead and add this to the recording for fun here. So a sub m, that's the value of a sub m, is 1 over n plus 8. I should write this series. Be more proper here. You can already tell, at least I can, that this is going to be a divergent series when you compare it to like a p-series. But let's show our work. We can do a comparison test or a limit comparison test. When I see something that looks like 1 over n, I want to compare it to it. So an will be 1 over n plus 8. bn is 1 over n. So which one's bigger?
AN is going to be bigger.
Is it?
Wait, no, sorry, BN.
bn's bigger, right? And we know that
Yeah.
bn diverges, right?
Yep.
Does that tell us anything about an?
Does it tell us that it converges as well, or?
Remember we said that if, when we're doing the direct comparison, if the smaller one diverges, then the bigger one also diverges. But this one's bigger, isn't it?
One is bigger than 1/8.
Yeah, so direct would not tell us anything here. Double check. This is small, bigger. Let me look at the notes.
Is it 9.5?
What's up?
We're doing 9. He's doing. This is 9.5.
Yeah, it's 9.5. I just want to double check the direct comparison rules. I'm pretty sure that's right, but I think we need to do limit comparison. What the hell is it? Oh, here it is. Oh, that's regular. Let's do limit comparison. Where is the stupid notes? Oh, if Bn converges, then An converges if An is smaller. If Bn is bigger, and that converges, then the small one must also converge. Now, for divergence, though, the smaller one must diverge, but this is the bigger one. So we will do limit instead, because this doesn't help.
The limit of A of n is 1/8, right?
What's up? This
Limit of A of n 1/8, because n is 0, so 0 plus
whole,
8, 1/8.
If you take this to infinity, the whole bottom is 0. Oh, sorry, the whole thing would go to 0. Sorry.
Oh, okay, got you.
So we're going to do limit comparisons, which says the limit of An over Bn, if that's equal to a value greater than 0, then both converge or both diverge. So direct comparison is best. Okay. Limit comparison.
So we're gonna say
Yeah.
A to the n plus 1 is equal to 1/n plus 8 is less than n plus.
So we use limit comparison since direct does not work with the chosen Bn. So limit of An over Bn as n goes to infinity is equal to the limit of 1/n plus 8 over n when I flip the fraction, which would be equal to what? One, right? Since the limit is greater than 0, then both An and Bn converge or diverge. But since Bn diverges, so does An. So this tells us that the series does not absolutely converge. So now we need to check, does it conditionally converge? Because we're doing this guy, right? We're not doing the original. So we're doing the absolute version because we're hoping if it converges, then we're done. But it does not. So yeah. Therefore, the original series does not converge absolutely. We must check for conditional convergence because this doesn't tell us anything about divergence. Do you guys remember the three conditions? Right, condition one. What was it?
Does it check to see if it diverges, right? Or am I thinking of another one?
So there's three conditions for conditional convergence. It's under the alternating series test. Remember we said we check for, actually there's two conditions, sorry. We
So
check
it's the limit as n approaches infinity,
Yeah.
if a of n is equal. Yep. And then the second one is the square root of n is less than the square root of n plus 1.
Well, that's a specific example. We were trying to
Ah,
show
okay.
if it was decreasing on that one, do you remember?
Yeah.
So let's
Okay.
see, is it decreasing in the next step? You agree that this will be 0, right? So that checks in.
Yes.
Oh, sorry, I forgot one thing. You don't do the negative alternating piece. You just do the AN. One second. Okay. As we can see, this is a 1 over n function, so it'll keep decreasing. So we don't really need to show it, but to be proper, we should. We know that n plus 8 will be bigger than n plus 9, right? So we know that 1 over n plus 8 will be less than 1 over n plus 9. This will decrease for all n. So this original series
Isn't that flipped? Wouldn't n plus 9 be greater
Oh,
than n
yeah.
plus 8?
You are right. Sorry, I'm dyslexic. I look made sense in my mind. There we go. Okay, so some will converge conditionally, but not absolutely. That makes sense? Is there any
Yes, it
steps
does.
that make sense?
Thank you.
Sure. You guys have any other questions then?
Not right now.
Okay, so we'll finish off chapter 9 on Wednesday, and then I guess we'll start thinking about the next exam. Probably next week.
We'll
Thank
review-
you.
Yeah, I need to figure out review time and all that. But yeah, we will. Talk about it Wednesday.
All right.
Oh, Professor, I have a question.
Mhm.
Are you giving in next semester, the spring, are you giving a differential equation, linear equation, because they open the registration and I want to register. So do you do any classes for?
Sadly, no. I mean, unless I can get 5 people, I will for sure do it and pay for the class on day one, like ahead of time. Then maybe I can convince them, but there's still a maybe, and I don't know if I can find 5 people.
Well, differential. Yeah, that's what I was looking. I was looking to see if they're going to offer it this semester.
I could maybe ask them for summer, because it might be too late for spring. But if I don't know, I guess I can send out like a poll and see who's interested, and you can vote
Yeah,
yes or
yeah.
no.
And I will tell my friends from the physics class. I have one mechanical engineer, one civil engineer. So if any one of them want to take the class, I will email you and let you know that I am one, he's one, and if you make 5, you can talk to the college. Don't know.
Yeah, if I have 5, it'll for sure make it, but I think that's like the minimum.
Minimum is 5 students.
Yeah, if we have more than that for sure, but if we go below 5, they're gonna cancel it.
Okay. All right.
But yeah, I mean, would you guys? Yeah, let me know if you're interested in doing it in the summer. I don't know if I could do it in the fall. It might be too late.
Okay.
Summer or spring will be fine with me.
Okay. Yeah, I'll send out some information soon. I'll talk to the scheduler this week. I won't forget.
All right.
Okay.
Thank you.